Yo! Hello and welcome back to the development diary of Saikyo, the cross-platform language learning app. Last time, we finally began to write our linear memory allocator, and we defined our widget struct with a few of the necessary components that we'll use to actually place widgets onto a screen for all to see. And we left off by saying that we'll fill in our widgets and hopefully get these showing on the screen soon. So that's what we're going to do this episode. We're going to fill in our widgets, and we're going to, uh, if we have time at the end, begin to talk about how we'll actually go about displaying these. So, without any further ado, let's just dive straight into it. So, there are, I suppose, before you begin to put things onto the screen, you kind of need to picture in your head what you want the app to look like what the size of everything will look like, and the various like relative sizes. Is the header going to be 32 pixels big, or is it going to be 64 pixels big, etc., etc. And I don't want to talk about design systems yet, but we will eventually use one. Probably material design, which is the design system that Google champions. But for the time being, we have one problem, which is that we don't know, given all of the data that UI is given, this UI function is given, we don't actually know how big the viewport is. We didn't pass that information down into this function. So that's a bit of an issue. And where are we going to get that information? We could get this we could stick inside of the composition one of our extent class, an instance of our extent structures here. So that way we could say like, oh, viewport is whatever, whatever. We could do that. We could wrap up the composition into another structure, and then we could pass that around. Maybe we could call that, say, like app UI or something like this. And then the viewport is more of a property of the app UI rather than of the composition proper. And I think that is what I'm going to do. So first thing I'm going to do is I'm going to move this down and stick it probably here, I would say. And then I'm going to make it one more struct. And we're going to call this app UI, I guess. And inside of app UI, we'll stick one of our composition things. We'll call this composition. And we'll also stick in an extent, and we will call this the viewport. And now let's go ahead and change our UI function so that it doesn't take in a composition directly, but takes in one of our app UIs. So we'll call this the app, like this. And we'll fix up the call site down here as well. So we have UI comp, but now we can just make this be UI. What's a really nice tip is when you're making a change like this, is that instead of going ahead and like changing the name of UI and then changing all the places of it, I just let the compiler, or in this case, CLion's syntax highlighting, tell me what needs to be fixed up. So we're going to change UI to be one of these app UI things. This is still a variable that doesn't exist, but I can just go very easily through and change all of these red places to be the new syntax that it needs to be to properly compile once again. And just like that, fix completed. And we'll fix this up down here as well. This will now be UI instead of UI comp. We'll come back to here, remove this because we don't need it anymore. We've done our refactoring. And here as well, we'll change this to be app UI. You are the app. And then finally, we are back up to par. And everything, this should compile. And it does. Awesome. And now that we've made this refactoring, we can very easily copy into our UI thing here, the viewport dimensions, which we did define up here inside of window dimensions. I should add, last time we made our extent be floating points, float 32s. And I mentioned that in experience, this is good for subpixel aliasing. One more good reason why you would want to do this is inside of NSRect, the AppKit rectangle thing, which is really an alias for a core graphics rect. There is an NS size, which is a CG size. And what does CG size contain? Floats, width, and height, but these are actually doubles. So AppKit's a little crazier. They don't even use floats. They use doubles, which is double the size, double the precision. It's not double the precision, but it's double the bits. So we're not the only ones who are making our extent be floating point. But one nice thing about this is that it will make copying this over nice and simple. So we can say that UI viewport is going to be win dimensions dot size dot width and win dimensions dot size dot height. Now, if only life was this simple, then this would let us continue programming with no problems. But in C++, when you use these braces like this, it will refuse to compile if the destination has a bit width which is smaller than the initializers. And because width and height here are both doubles, but our viewport is composed of floats, then this won't work unless we force the conversion with typecasts. So that's a small tip to avoid the so-called uniform initialization. I'm going to call it the uniform initialization headache, but whatever. So now we have our viewport. If we go back and we execute inside of our UI here, we'll jump in. Did we get the right things? And we did. So we know that our viewport is 400 by 400. And we're going to use this information. So I'm going to come out here and let's make this a const order. Our viewport will be equal to app. Thank you. App viewport. So let's make this really simple to begin with. The first thing is we'll make the widget. Actually, I'm going to call this maybe WGT. Yeah, we'll call this WGT instead because W is too easily confused with width. We'll make this super simple. We'll say that our widget's position should just be 0, 0. So you start in the very top left corner. And then your size, we'll make the width be equal to the viewport's width. So that way it stretches across. And we'll make the height be, let's make the 64 pixels high. And then similarly, we'll come here and we'll say to the widget's size, I want the footer, the footer's width to be, again, the width of the viewport. That's not going to change. And I want the height of the, where is it, position? Nope, it is size. I want the height of the footer to be, let's make it 32 high, so we can see a little difference between the header and the footer. But the million-dollar question is the position. Well, it's going to start on the left edge, so that's easy. But what is the Y position of the widget? How are we going to calculate this? This will depend on the size of the body, but with the body, how tall is the body going to be? Well, I want the body to be the height of the viewport, but then minus the heights of the header and the footer. And so this is the main brilliance when it comes to using immediate mode GUIs, because instead of going through and being like, I want to, symbolically declare, say, the footer, the body should be, parent, height, and then doing some sort of weird referencing to get the header and the footer, or we have to do something like we give the body a weight, so that way it would naturally or automatically expand. We don't do any of that crazy weirdness. None of that bullshit. Instead, we have the widgets. We are deciding where they're going to be, so we can just go ahead and we can just calculate it right here. Nice and simple. Nothing hard to do at all. So the first thing is I will make a variable here. And we'll say const order footer height, since we will need this, which we said it's going to be 32. And I'll stick that down here as well. You're the footer height. And here's where the magic happens. So we'll say that the position of our body, you know what? I will actually rename this to be body header. And down here, you, my friend, can be the footer. And then we'll just go here, change this to be FTR, you are HDR, and then you are body. So our body's position, still everything starts on the left-hand edge. So that's why the x coordinate is 0. But your y position, you, my friend, begin underneath the header. So this is the reason why I made the compose function return a variable, because now we can reference it down here. So the header's height is where our body will begin. So it will be directly underneath the body. And now the body's size, again, I'm going to make the width be the width of the viewport. It's the same. And then the height of the body will be equal to the viewport's height minus the header's height plus the footer height, like this. Now I could put the body underneath the footer, and then in the same way that we're storing the header widget, we could store the footer widget and then reference them both down here. We could do that. In my mind, though, it's a little easier to visualize what the UI will look like if we write the code which generates the UI in the order that we expect the UI to be. Kind of as if we're writing HTML or something like this. And I don't know if there's like a right way or a wrong way to do that. Since these are all at the same conceptual like level or depth of the UI, it's not going to make a difference in terms of the drawing order or anything like that yet, anyway. But in my mind, it's just easier to do it like this. So we just make the footer height be a variable. If this was calculated anyway, we could still like do the calculation beforehand. All right, cool. And then I will store the body here. And now, where will the footer be? The footer will be the body's height its y position plus the body's height. If we had just put the height here, then this will have collided with the body a little bit. It would have overlapped. So that's why we moved it to where the body starts plus the body's height. So that way we're like slowly accumulating the progression down the screen. And I think that would do it in terms of placement. Everything has its height and its size determined. So the only thing that's remaining now is to set the color. So let's set the color. So what color should the header be? Let's start off by making this a maybe azure blue. I like the color blue. So azure blue hex. It's a very deep blue. A web safe color is apparently this color. What is this color? It looks basically the same. So 0066FF. And there's a hidden another FF here for the alpha channel. So this is RGB. And it's 2 by 2. So that's the red component, G component, green component, blue component. So let's do that. I want to make this easy to, like, say, grab a color like this, and then just copy the values and then stick them into here, instead of having to say, like, you know, oh, what's 66 divided by 255, etc., etc. Because the hex colors would have been integers. This would range between 0 and FF, or 0 and 255. But we're storing the colors as floating points. So let's make a nice little convenience conversion function to do that for us. That way we only have to do it once. So we'll call this RGB. RGB. Yeah, that's good. And we'll make it take in, let's make this take in int32s. So this will be the R. This is the G. And you are int32, the B. And also take in an alpha, but we'll just set the alpha to be the max to begin with, OXFF. And you, my friend, will return a color. Sweet. So we'll make the color. Col is a color like this. I guess we'll actually do it like this. And then the red component will be equal to the red component divided by 255. And we'll just repeat this pattern for all of the other color channels as well. And then finally, also, we need to have the A alpha channel. And we will return the color at the end. Sweet. What's wrong with you? Uninitialized record type call. Yeah, obviously we initialize it directly afterwards. So you're kind of a little bit stupid there, Clang Tidy. This is one of the problems with modern C++, which is that even though it would be completely possible for a static analysis tool to look at this code and realize, oh, all of the fields of this record type are being filled in and not read, like they're being written before they're read, so they're being properly initialized and then returned. It could do that. It doesn't do that. It's like, oh, what's that? You declared a variable without initializing it there and then in the same line. That's a warning. It's just stupid. So I'm gonna do this. Turn that crap off. There we go. Nice and easy. Sweet. So what this code essentially does is it will normalize the red, green, and blue channels to be floating points, and that will work. All right, cool. We'll come back into our UI, and we will call our RGB function now ourselves. So what were the values again? It was 0, 0, so OX00, OX00, OX66, OXFF. And now our color will be perfectly set. So yay for us. The body's color, I want this to be like a slight off-white. Could I have like an off-white background color hex? What do we got here? I mean, this looks pretty off-white to me. I can't tell if it's not loaded or if it's like meant to be this color. I honestly cannot tell. But let's just assume that this color, it looks okay. So FA, F9, F6. RGB. OX, FA, OX, F9, OX, F6. Sweet. And finally, what color shall we make the footer be? I suppose we'll make the color be at the start some sort of like magenta. What's a nice magenta? Magenta hex. Yeah, I mean, that looks pretty ghastly. We'll go with this. So it's like all red, no green, all blue. So that's easy. OXFF, OX00, OXFF. There we go. Okay, whoops, sorry. Looking pretty good to me. So just for a quick sanity check, let's re-execute this code and make sure that we have values that we are expecting. So if I just come down here, our header, position, 0, 0, that's right. Size, 464, looking good. And our color is this, which you can't quite tell what it is, but it's 40% green, 100% blue, no red, and not transparent. So that's looking like it's okay. We'll check out our body. Can you please? Okay. Okay, that's weird, but okay. Our body position is on the left edge, starting at 64, so that's doing the right thing. It is 400 wide, 304 height, so that's looking fine. Because 32 plus 64 is 96, 96 plus 304 is 400, and that is the size of the viewport. So that's right. And then our color is 98% white, 97.6% white, green, sorry. 98% red, this percent green, this percent blue. So that's probably okay. And then finally, if we come down here and we look at our footer, what do we got? Position, 368. That's right, 368 plus 32 will put us at 400. So that's at the correct position. The size, looking good. And the color, probably going to look absolutely terrible. Magenta is such a stark contrast color. But it looks like all of our values are completely okay. So it looks like everything is good. So we did it. We inside of our UI thing, our composition, 104, right? 32 times 3. Is that right? That may not be right. 32 times 3 should be 96. But we're off by 8. So looks like our code from before is a little bit broken, maybe. So let's go quickly debug this, see what's happening, see what's going on. So if we take a look at our widgets here, so current's at 32, looks like that did the right thing. So the next time we call compose and we go to allocate this, probably we're jumping forward a little bit too much because this code may not be correct. So if we take a quick look here, current is already aligned on a 4-byte boundary, so this should be 0. Oh, sorry, it should be 32, but this might jump up to 36, and it did. So this check here is busted. Let's fix it. So what we want to do is we just want to check to see whether or not current mod alignment is equal to 0. That's what we want to check, but because we know alignment will be a power of 2, we don't necessarily want to use the modulus operation. We can just use bit shifting operations. If we AND current and alignment together, would that give us what we want? It may not. Let me think quickly here. Well, let's use our example. So we have alignment being 4, which is equal to OB110, 100, sorry. And current is equal to 32, which is OB11234. And I'll pad these out to be the same width to make this easier. So if we just AND these two things together, we're going to get, well, 0. But even if I had a 1 here and I ended these together, they would still be 0. So that's not very useful for us. But if I did 3, which is OB11, bum, 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 bum. If I took OB11, and added these together, this would give me, this should have given me the right answer, which is that no, 33 is not a multiple of but if sorry, it's probably this. Probably shouldn't have flipped those. That's almost certainly what the problem was. Because, so just to go through that one. So 1, 2, 3, 1, 1. This is alignment minus 1, but I was flipping this so that this would have become OB 1, 1, 1, 0, 0. And that is not correct. I just want to see whether or not the final two bits are lit up on the current. So that's probably the answer. Let's take a look-see. So this was when we allocate body. So current here is 32. Current should still be 32. And now it is. Okay, I think we've probably fixed this. Now if we take a look-see at our composition, widgets, yep, 3 times 32. That's what I was expecting. See, it goes to show you, this is the power of C and C++. You can do anything, but sometimes whether you should do it is a very different question from whether you can do it. So we could make this even better. We could like store the result of alignment minus 1 so that way we don't recalculate it twice, but I don't particularly care. So there we go. We did it. Just remove this. And looks like we're in the perfect position to talk about rendering out the widgets. And that's what we'll do in the next episode. So next time, we'll figure out how we're going to actually stick things into our window, which we haven't actually done so far. But that's pretty cool. It may not look like very much, and granted, these will definitely not look like anything, even remotely resembling an app. But we're laying down the foundation such that once we get this all correct, we'll just keep iterating on the design that we have here, and eventually we'll be off to the races. So I'm looking forward to that. Thank you so much for watching this episode of the Development Diary of Saikyo, the cross-platform language learning app. Don't forget, if you have any questions, drop me a comment, and I'll take a look-see at them, and I will answer them. So, until next time, take care.